put it on a board with a knitting needle, place glass on top, and then roll it backwards and forwards to make a piece of filament like spaghetti. And then you would do this again and again and again, and we made the filament by hand. There isn't much point in designing a machine to replicate itself and then spend the rest of your life in courts trying to stop people replicating it. The only way to make it really easy for it to reproduce was to open source the design.
I just had the chance to talk to the inventor of the first desktop 3D printer.
I'm Vic Oliver. I was the first person to 3D print a 3D printer. And that was done as part of the RepRap project, which was started by Dr. Adrian Bowyer of Bath University in the UK. And he didn't actually know that they were going to do a 3D printer at the time. His idea was to create a device that could replicate itself and make other useful things. And I was working on some technology for space, for use in space, in life support systems. And I needed a machine that could fix, make spare parts for life support, because you can't use FedEx in space. And the machine had to be able to make its own parts so that it could keep repairing the life support system. So I saw Dr. Bowyer's letter in New Scientist, and I replied to him saying, "Hey, I'm working on something like that." And he said, "Do you think it would be any use on Earth?" And I went, yeah, probably. And he asked me if I wanted to join the project, and I did. And that was basically the beginnings of RepRap. Yeah.
Oh, great.
So that I think is the short version. Hello, Kiefer. Kiefer. Yeah. It's okay.
There he is.
Yeah.
All right.
Okay.
It's like all those 3D printers we see now. Are they kind of children's from that idea, or is it?
Yeah.
different?
Well, the first thing we did when we made the Mark I was use the Mark I to make a part to repair itself because it got damaged. We learned a lot of things from making the Mark I. And we learned that we needed a more stable design, so we went to design the Mark II, which obvious thing to do. The Mark II I got hold of, I made one in New Zealand, and it was very difficult for me to make in New Zealand, so I changed the design to use parts that I could get in New Zealand. Continuous drive belt, not really possible to get in New Zealand. I replaced it with ball chain. There were a few other modifications. The little tiny roller bearings, very hard to get, so I used solid blocks. And I had this design working, and actually there was a Fab Lab as well, and I took that design to a Fab Lab, and we tried to figure out what was the best way to make it in a Fab Lab. And that ended up with a sort of Kiwi version of the Mark II, the Kiwi Mendel. And then I was contacted by a guy called Josef Prusa, and he said, "This looks good. Do you mind if I take this design and go and make something commercial out of it?" And I said, "No, go ahead, help yourself." And he did, and Prusa. Yeah, so that's one thing that happened.
When was that? In which year?
I can't remember, to be
Roughly,
honest. Yeah,
a few years ago, right?
Gosh, it would have been 2009, about, I
So
think.
more than 10 years ago.
Gosh, yes.
All right.
I think a long time ago. It may have been a little later. I'm not sure how long it took me to do the modifications to the Mark II. But I think the Mark II came out about a year. So the Mendel machine, we called it, came out about a year after the Darwin, I think, something like that. It wasn't very long. But you were saying what were the thoughts and processes that went on. Actually, a lot of the thought and processes went on before we actually finished making the Mark I. We knew what would happen when we created this machine and everybody got hold of it. We knew that there would be people making good things and people making bad things, we hoped that there would be more people than bad people, and that seems to be what happened. There's one thing we knew for sure, all right, because this has happened through every technology that man has developed, okay? And there were three things that we knew that people would make. We knew that they would make weapons with it. We knew that they would make sex toys with it, and we knew that they would make drugs paraphernalia with it. Not particularly because of what a 3D printer is, but because that's what's happened with just about every technology that mankind has come across. Yeah, so we were ready for that, but yeah, mostly we thought that people would take it and evolve it to do useful things, particularly in medicine, because of the open source design. If people wanted to start 3D printing things for use in medical research, we thought they would probably use machines that were based on the RepRap technology. Because if you could imagine someone going to, say, Stratasys, for example, and saying, hi there, we're going to do some medical research and we'd like all your software and technical specifications so we can muck around with your machine and, I don't know, print body parts with it. Yeah, and they probably wouldn't want to do that. But you say that to people in the RepRap project and it's, hey, that sounds like a cool idea, how can we help? Yeah.
Well, you told me about the open source ideas in the beginning, so you were very aware of how you want to make it.
Yeah.
So it was not just giving out somehow, but
no, it was part of the design.
Right.
I mean, there isn't much point in designing a machine to replicate itself and then spend the rest of your life in courts trying to stop people replicating it. That was the whole point. We knew that it would evolve. In order to evolve, we had to make it easy for it to reproduce. The only way to make it really easy for it to reproduce was to open source the design. And also, when I invented the PLA filament for the printers, which we put a lot of thought into what plastics could be used. I didn't patent PLA filament either.
So how did you make sure that it is open source and stays open source? What was the thing you did?
Well, basically, we published in scientific journals our papers. And once you have published a paper in a respected journal, then the idea becomes in the, I think the term is eminent domain, and so nobody else can try and patent it from you. We did actually have to wait for some patents to expire on fusion deposition modeling and stuff that Stratasys held, but those were very old and some would say very obvious patents, and they didn't stop us doing our research, because it's legal to make things that are patented for research. We also knew that it's legal to make things for yourself if they're patented, as long as you don't sell them or offer a service that is based on them. If something is patented, you can make one. There's nothing to stop you doing that. But it keeps things a lot simpler if everything is out of patent. So that's what we did.
You also, not only the machine, but also the filament you did.
Yeah.
So, and then like Prusa called you, and like many others didn't call you, but they like looked at it and made their like.
Yeah.
So they're like multiple, many.
Eric from Ultimaker as well. Yes, we had a lot of discussions with him. He's the one who said, yeah, I'll use 3mm filament, I think, and so we settled the design on 3mm. Though that's basically because we had 3mm knitting needles, and we were using 3mm knitting needles as the forms to make the first filament that we made. That was made from kappa, polycaprolactone, which melts at 70 Celsius. So we could form it with our hands, and we would melt the granules in hot water with a fork, and then take a lump of the softened plastic, roll it into a sausage, put it on a board with a knitting needle, place glass on top, and then roll it backwards and forwards to make a piece of filament like spaghetti. And then you would take two of these and a lighter, and you would melt the ends and join them together, and then you would do this again and again and again, and we made the filament by hand. Occasionally we would be running the machine and trying to make the filament faster than the machine was using it.
Crazy.
Yeah, I took one of the early machines to Vienna, and I remember at an exhibition there, rapidly trying to make filament, talk to people, and have this machine run at the same time.
Cool.
Yeah.
So would you describe yourself as the inventor of 3D printing machines, or?
No, this was a team.
Okay, but your team could be described as like the inventor team?
Yeah, I mean, well, we didn't even invent 3D printing. 3D printing existed for a long time. I think the original concept was invented by someone who went by the nickname of Daedalus in New Scientist magazine, the same one that Dr. Bowyer put his letter to the world in. And he suggested using using a liquid polymer that could be polymerized with a laser, and scanning patterns in the polymer to harden it and build it up layer by layer. So the concept was around for a long time. Stratasys had made 3D printers by the time when we were doing the RepRap. That's actually what the first RepRap parts were made with, was a giant Stratasys FDM, but they cost, I don't know, about £100,000. They used expensive cartridges of filament. The whole RepRap cost less than one cartridge of filament for the Stratasys machine. You had to have a maintenance contract. They ran in that they had an enclosed chamber which controlled temperature conditions and everything. It was something that maybe a university had or a big industrial company. It wasn't something that you had on your desk. And that's really what we invented.
So you invented the machine for the desk.
We invented the machine for the desk, really. But it wasn't just the machine. There was a whole ecosystem of parts that you need to have to make a 3D printer that everybody thinks of as commonplace now. Stepper motors, drive belt, drive pulleys, stepper motor drivers, controller boards, all these things weren't really accessible to the average hobbyist when we created the Rep Wrap. We were molding our own belt gears for the Rep Wrap, right? I was substituting continuous belt for with the ball chain that you use on blinds and make little key rings and things out of. I used that to make drive belts because I couldn't get real drive belt. We were very lucky. At the time of the launch, there was this wonderful new open source project called the Arduino, right? Which is what the first Rep Wrap used. Before that, we were actually making our own little controllers using PICs with a loop RS-232 network, one PIC per axis and one for the extruder, passing little messages around a loop.
I just think the music is getting louder.
Yeah, definitely.
So I have one last question, but maybe we switch places.
We've teleported. Okay. Yeah. So anyway, the electronics, we were using the Arduino, but things like the ramps boards and so forth. One of the things the Rep Wrap project did was to establish some kind of standard for creating open source hardware for making 3D printers. And of course, all the other hobbyists, whenever they needed a multi-axis driver for stepper motors, would use the 3D printer component. Because it was a standard, because it was available, and because there was more than one manufacturer and they were starting to become cheap. And it wasn't long before all the Chinese manufacturers were falling over themselves to produce common parts really cheaply. And that's one of the things that the Rep Wrap project started moving that people don't really think about very much these days. Yeah,
actually,
I mean, we probably weren't the first, and we definitely weren't the only, but we were definitely a substantial part of that drive to common parts of open source hardware.
Well, yeah, I remember about around 2008 maybe. I heard the first time about your project, like a colleague of mine in university. He was like, "Oh, there's a machine that can build itself," and he was kind of like in. Before that, like we had this fridge-size big printer in our lab at the university.
Yep.
But that was 20,000 euros or more, I don't know. And so he said, "There's a new one that can build itself," and so that was kind of a spark or something that also inspired people or got the interest. So that
it's amazing how many people were reluctant to believe it. I remember having people telling me that it was not possible to build a machine that replicated itself while I had one on the desk in front of me. All right.
Well, they probably argued that you didn't replicate everything, right?
There's
not the metal. You don't print metal with them. Yeah, but maybe that was a point they had.
There's a difference between replicating and duplicating. All right. So, a virus. I think we've had one of those recently somewhere, haven't we? A virus replicates, okay, but it can't copy itself. It doesn't have the ability to make all the parts it needs to replicate itself, and yet it replicates. It does the same thing that the RepRap project did. It fools humans into doing all the hard work of replication for it. So, humans are just a RepRap's way of making more RepRaps.
Okay, maybe like the last question would be like looking to the future. So there's like many projects. So at the Fab Fest we saw clay printers,
Yep.
there are metal printers, and all kinds of printers that is maybe like a robot welding something, but
Yeah.
this layer technique. So we have a lot of things. How do you see this development? What do you see coming in the future? What do you see as most interesting outcomes we can expect future?
Well, what I see in the future, and I'm not entirely sure how open source is going to handle this, because it's different again. I think that the materials that 3D printers use are going to get smart. All right. So it is going to be about making smarter materials rather than smarter machines, as it were. What I hope is going to happen, this was my thought right from the beginning when I started, even before I thought of RepRap, even before I'd heard of RepRap rather, is that we have the ability to make smaller and smaller things, and we have the ability to make bigger and bigger and more complicated molecules. And at some point, the biggest molecule we can make is going to be able to interface with the smallest machine we can make. And at that point, we will have control from the macro scale down to the atomic scale, and we will be able to make anything we want to. What I hope is going to happen is that the same kind of spirit that was behind RepRap and 3D printing will help to develop this technology. That's
Cool.
what I hope.
And what do you mean by smart materials? Give an example.
So materials that can change shape or change physical characteristics, not just while you're printing them, but afterwards. So smart materials, flexible robotics, that kind of thing. But with the materials playing a role in the formation of the object, rather than simply being layered up.
All right. So, and the printer is kind of in my perspective, the core technology for makers and for like a Fab Lab. It's like every Fab Lab, the first machine they buy is probably a printer. I don't know.
Yeah, they're cheap these days, right?
Yeah, so you can get them for 150 euros.
Which costs more, a 3D printer or a vinyl cutter? Yeah.
Yeah.
If you want to get a good vinyl cutter, you're going to be paying more money than you would for a 3D printer.
Right. Yeah.
Yeah, I can see a wider range of materials becoming more common. I don't know how, but I know that people want it, and that things will evolve in that direction. There has been some fascinating work going on with hydrogels at the moment, which allow a hydrogel to contain a metal salt, for example. And then when you heat the hydrogel with the metal salt, it decomposes into the metal. All right? And this can be done at the macro scale and the micro scale. So, if you have different quantities of oxides and things in there, you can make ceramics instead of metals. It's kind of a smart material. So, I can see that kind of technology being adopted. It's relatively non-toxic compared to, say, resin printers, and it allows you to change the properties of the material after you've printed it. So there are a few interesting things in the pipeline. I've no idea which one will come out on top. I'm going to try and find, if anybody would like to come and lend me one of those little lithography style printers that can sort of 3D print on the micron scale. I'd really like to make a really tiny rep wrap, maybe for our 20th anniversary or something. That would be really cool. All right.
Thank you. I think we stop here.
Absolutely.